Hey folks, Quill18 here, and welcome to a post-mortem for Wake Up Call, my entry for Ludum Dare 36. This is my 15th Ludum Dare in a row. Ludum Dare is a 48-hour game programming competition. You get a theme announced on Friday night, and you have until Sunday night to make a game. I do sleep, but other than that, I'm basically cramming in a full week's worth of work into 2 days, and it is incredibly fun, and definitely recommend that anyone try it. But it is also very, very exhausting. It's going to take me a few more days before I am functional again. But I'm so happy to have done it, and the whole thing was live streamed. The raw videos of that don't get uploaded to YouTube because I'm always listening to music throughout. So we're going to have this, and I'll also try to get a time-lapse video up online for you guys. Hopefully everything recorded okay. No promises yet, because sometimes weird things happen. Anyway, what I want to do in this video is I want to go through the project, do a bit of an overview about how it works, what went well, what didn't go well, that sort of thing. Talk about the experience in general, and I will point out that you can get the source code. It's hosted over here on GitHub, and if you check the link down below, you'll get a link to this page here, which is my entry. So, what is the game? Well, first of all, the theme this time around for Ludum Dare was ancient technology, and I decided to approach this theme in two separate ways. One, I did a pure console roguelike game. Very, very old school. It was programmed in C#, but other than that, there are no external libraries, no graphic libraries whatsoever. 99% of the functions that we interacted with were functions that belong to the console library. So console.setCursor, console.writing a character, console.read character, read key, so we can get some input and output, and that's basically it. It just runs entirely in a text console. Currently, at the time I'm recording this video, there's only the Windows build available. However, it actually does run on Mac and Linux if you have Mono installed. You can just use the Mono command line and then to run that executable perfectly fine. And I will be building a standalone Mac build. In fact, by the time you watch this, it might be on the page. I don't have the setup to do a standalone Linux build, but again, if you have Mono installed, then you can just go ahead and run that. So, yeah, pure C#. Let's load up the game over here. I've got it running. This is what happens when you start the game right after the intro, and you can move around with the numpad or arrow keys. Very standard roguelike controls. There's a list of hotkeys over here, including the help screen, to give you some more information. And as you move around, you can pick up stuff. You can use the L button to use a cursor to look at things. So there's a small battery, and if I hit enter there, I can get more information about it, and we can look around our environment that way. Combat is handled in the classic roguelike, and by roguelike, I mean actually like the old game called Rogue, of which the big descendants are things like NetHack, Dungeon Crawl, Stone Soup. Cataclysm Dark Days Ahead is an excellent example of a modern roguelike, for example. Oh god, there's many more. Here's our first enemy here, a Reptoid Foot Soldier. So the story in this particular game, so again, one of the ways I approached the ancient technology theme was mechanically, in that I used this console-based text-like rogue type thing. But the other thing, you are a warbot. You are a robot built for war, but sometime after you're built, Earth declared peace. I'm gonna put a bucket on my head. They ceased all warfare, therefore making you obsolete, so you got stored in a bunker. And then thousands of years later, Earth, which is still, a world completely 100% at peace, gets invaded by aliens. They have no way to defend themselves, so they try to reactivate any dormant warbots that might still be around, and you are the only one to wake up, and you are broken. Most of your systems are corroded, offline, and simply non-functional. So you yourself are ancient technology. Although, certainly from our perspective, in our timeline, the idea of a warbot does not feel particularly ancient, but is still the twist that I was going with. And I thought it was pretty good. Not the only one who went with the idea of sort of like obsolete technology. Let's go and eat a battery here. As a way to interpret the theme. But, so I like it. I think it's quite a good way to do it. And so the combination of the mechanics and the theme itself is going to be alright. Let's go ahead and install the pneumatic piston into our leg slot. So we're trying to rebuild ourselves so that we can get to the bottom of this military storage bunker to get the Yendorian power cell, which will bring us to full power, because right now we're operating on 0.1% of our maximum power, and also so we can wake up more of the bots. Here we go. We can spend some more scrap here. I'm going to get a couple of levels of vision, a little bit more fuel efficiency, armor plating, a couple of ranks of melee damage boost. There we go. That's going to be a lot better. Oh, it's nice to have a little bit more vision. Right away, you get an interesting choice in that... I need a key. You get 2 head slot items on the first level. You get the webcam, which gives you +1 vision, and you also get the bucket that you can put on your head, which actually gives you +1 to damage resistance, but it also reduces your vision radius by 1. So effectively, there's a 2-tile difference in radius between whether you equip the webcam or the bucket. And having the bucket on your head does feel a lot like you're walking around blind, which is entirely the idea. So I still have the bucket now, but I've gone ahead and upped my base stats. Let's see, we've got some WD-41 here we can use to heal ourselves up. So alright, that's the game. I don't want to go and play through it all. The levels are not procedurally generated, and we're going to talk about why that is momentarily. There we go. I guess this is a good place to stop. So that's the gameplay. That's the page. And let's talk about the game programming over here. So this is the project over here. I should go ahead and close all these windows, and then we can open them sort of one at a time and talk about the progress. But one thing I do want to show right away is this is how all of our levels were designed. These are literally my levels. I just wrote out these strings and these characters, and when I load the game, I read all of these strings in, and then I build the levels based on this. This is not what actually gets printed on the screen. It just so happens that each one of these symbols maps to some tile data that is then represented on the screen with basically the same symbols. Not all of them. You can see a 0, 1, and 2 over here. These correspond to some of the special items. That's the bucket over here, this is the bent girder, and this is the webcam, and that's all designed by some extra data down here. So, but why not do procedurally generated levels? Well, obviously, that's the way you would want to do it normally. In one of the classic features of roguelikes are replayability via random content generation, and it's an important part of the genre, and it certainly just in general makes games more replayable. But in a game jam like this, it's really important to make decisions about how to spend your time. And in practice, making a procedurally generated level generator is not horribly difficult or horribly time-consuming, but the time-consuming bits are really about how to, like, tuning it so that the levels really feel interesting and playable and varied. Whereas handcrafting the levels, you can guarantee that the levels will have the right balance of enemies and items and so on and so forth quite easily, because literally if like a room is too hard, I can just say, let's spawn 1 fewer of the foot soldiers over here. Or things are too easy, I can come back and introduce a bunch more villains that way and then have to deal with that. And then you sort of tune it that way through a couple of playthroughs. And because it's not procedurally generated, not randomized, the playthrough is exactly the same every time so that I can tune it. And in a game jam, 2 things. One, most people only play a game once and often won't play a game for more than 5 or 10 minutes anyway, so I aim for a shorter sort of game. This one actually takes about 30 minutes to play through. At least it did when I did my run after Ludum Dare. I played through the whole game from start to finish, and it took me about 30 minutes to do so. So that seems like a pretty solid amount of content. For a jam game, that's a lot. That's a good amount of content. You got to think about it this way. On average, the average person who participates in Ludum Dare ranks somewhere between 10 to 100 different games. And so there's, you can't ask someone to play something for 2 hours, and to make a game that it's playable for over 2 hours would be ridiculous in 48 hours. So there's that. And yeah, tuning the procedurally generated algorithm would take a lot more time. And so, because I've done that before, I did Ink, which is a game that has a lot of really strong features, but one of the things we sank a lot of time into was tuning the level generation, making sure the graphics work, like how to make sure the walls show up properly, for example, for connecting all these rooms. And by just cutting that out here, it was awesome. I did have to go and, draw these levels, but it meant that each one of the levels could feel quite different from one another and have a bit of a theme going on. Some are very inspired by NetHack. In fact, some of these things, what I did is I looked up screenshots of people playing NetHack and sort of used those level layouts as some of the general ideas. So almost taking advantage of a pre-existing random level generator. But then, get levels that are meant to work, slightly differently, feel slightly differently, and here's the end level over there. So I really think that was an excellent decision. I don't regret it one bit. Although, if someone were to go and make this into a more real game, the first thing you'd want to do is add procedural level generation, and then spend several days tweaking that and combining that with pre-made levels as well to give you the right amount of variety. Anyway, so what's the main loop of the program? How does... oh yeah, I messed around with that map, that's true. Well, the main function is over here in the program.cs file. Here is main that runs it. It sets a console color and just executes a run game function, which is on a loop. And run game by itself doesn't do much either. It actually hides the cursor, which honestly should have been done over here, but that's okay. What it does is it instantiates the game object. It instantiates an intro and then plays the intro, and then it just starts a main loop with the game that also happens to have a little sleep in there. That could have been somewhere else. A bit of redundancy in the main loopy kind of thing, but that's okay. And at some point, game.update will return false, at which point we bust out of there. If the and then we return the game.restart flag, which will indicate to us whether we should keep the main game running. So if this is set to true when we return here, we call run game again, which reinstantiates a new game, plays the intro again, so on and so forth. So obviously the main guts of everything is in this game class. And the game class is actually a great example of something that started off really clean and very well organized, but over the course of a jam tends to grow a little bit out of control, because one of the things you don't really have time to do is stop and really do a good refactor of your code to keep things really clean. My goal with these game jams, and again, I've done 15 Ludum Dares at this point, my goal is to try to start as clean as possible, but with the understanding that when we get about halfway through, there's going to start to be that mounting time pressure, and you're just going to have to start sort of just throwing things in there and making it work. And the idea is to end up with a bit of a balance of well-organized and structurally sound code at the start, such that you don't paint yourself in a corner where everything takes so much more time and things are more buggy, right? So you've got to do enough sort of basic scaffolding in a sane way so that your program can continue to move forward. But then later on, sacrifice the thinking of what's the best way to organize everything. Just get shit done and hope that the basis of your program is sound enough to keep that going. There's always going to be a little bit of sloppiness going forward, and it was just funny for me to watch that progress happen again every time. That's exactly what happens, and you're talking about things like fields becoming more and more just public and open, so that I'm fiddling with bits from other part of the code so I don't have to write accessor functions and sanity checks and that, which again you want to put into place as early as possible, but later on you don't have time for that. You just have to trust, well, there's only one person working on this, which is me, so, and it's all happening within 48 hours, which means I have the whole program uploaded into my brain. I'm not as worried about fiddling with a field in some object somewhere in such a way that might make something else break, because I more or less have it all in my head. And so you're sort of gambling on there, but that's one of the ways you try to squeeze things in the right amount of time. And then, certainly I could take an extra day after. I could take a day now, redo all this code with, comments, proper encapsulation to keep things good and clean and all that. And that's something you do after the fact. But anyway, this is the constructor for the game. We set up one of the big things that I built, and this was part of my practice a week before Ludum Dare, because a couple of things. This is like the 5th or 6th time I've talked about doing a text-based-ish game in some way, doing something like Zork or something that feels like an old BBS door game, or one of these kind of roguelike-y things. I've been wanting to do something like that for a while, and so it's been in my head before. And again, I always do a little bit of sort of programming warm-up and practice before Ludum Dare to get my brain in the right place, and I happened to fiddle a little bit with text-based stuff, and early on in the voting, it was quite clear that ancient technology was getting a lot of there's a lot of momentum behind that potentially becoming the winning theme. And I thought that, well, that meshes really well with the idea of doing a pure text-based thing. So I did some practice to see how it works. How do you interact with the console in C#? And more importantly, what's the performance like? And it turns out that the performance of the console is kind of poor, especially if you're used to working in an environment like Unity or something like that, which can handle hundreds or thousands of, especially say 2D sprites on the screen and perform perfectly fine for a couple of different reasons. One has to do with how those sprites get pushed out to the graphic card and then get handled in hardware, but also because of behind the scenes optimization that Unity does in terms of, well, both Unity and your graphic card does in terms of knowing that, well, this thing didn't move or change, therefore we sort of don't have to redraw it and we can optimize it. But that sort of thing doesn't happen in the console. So I actually generated my own frame buffer class over here. And this one here is actually pretty much fine. If I threw some comments in here, I'm pretty sure that it would be like, I would be happy to have people use this. So this is a frame buffer for a console. And it is paired with this Chixel class. This is a character element or character pixel, right? As opposed to just a pixel. So this defines our pixels. Because here's the thing. There was an interesting, this is issues I ran in earlier when I was doing my test and discovering that things are quite slow. You can write out to the console a whole bunch of characters. In fact, you can make an array. So by default, your console is like 80 characters wide by 24 characters tall or something like that. But you can resize it and you can get that information. The console class in C# tells you the size of the window and things like that. And you could instantiate an array of characters that is, as big as, say, 80 times 24. That's the size of your array. And you can dump that whole array of characters to the console as one write, and it's very fast. Very fast. I mean, we're talking about thousands of FPS at that point. The problem is, if you do that, you can't embed color information. Depending on your particular environment, you may be able to spit out a certain amount of ANSI color code information to the console. But even then, I found like it slows down dramatically. If you end up in a situation where your characters are sort of changing color, every other character is drawn in a different color, it's going to run apocalyptically slow. And that's true whether you are outputting ANSI codes within your string, at least in the testing I did, or if you are setting the code, because console.foreground color and console.background color, you can set foreground colors and background colors that way. I think behind the scenes what's actually happening in the code is it's then outputting the ANSI color code at that point. So I think that's why the performance seems to be basically identical whether I output ANSI color codes or use console.foreground color and background color. But yeah, and we're talking about, instead of thousands of FPS, we're talking about 3 frames per second, especially if you've got a console window that is made bigger. Now here, I made the font quite big, but like your default font in this is, I think, size 14, maybe even size 12. Now, size 14, that looks about right. Very tiny, and there's no reason you can't stretch this out. Now, in my program here, I only draw in this area regardless, but you can make it bigger. In fact, one of the examples I could show you as well, assuming I still have it around, binary release. Does this work? There we go. This is my Perline noise generator. And so, this scales to be the size of things. And if I were to zoom out to such a point where things get very noisy here and not particularly sensical, but this sort of like redrawing of, it's having to change colors quite frequently because of the water. You can see here that render, it's not running constantly, but the amount of time it took to draw this entire rectangle means we'd be running at about 5 FPS. Whereas if I zoom in, well, okay, this might be a bad example because it still seems to be running quite slowly, probably because of the way I have this particular example constructed, but it wouldn't be very fast for those full screen redraws. So anyway, all that to be said, what I did is I implemented this idea of a frame buffer, basically, where rather than my code writing directly to the console, I instead write to the frame buffer, and because I want things to be in color, I made this Chixel class so that for each sort of character pixel on my screen, I would have an instance of the Chixel, which has the glyph, i.e. the actual character, you know, the letter A or a slash or an ampersand sign, for example, and as well as color information. And it's got this dirty bit, this dirty flag, whether that indicates whether the Chixel will have to be redrawn or not. That way, the frame buffer, when it goes through its main loop of draw frame over here, it checks to see if the Chixel is dirty, and if it's not, it doesn't bother doing the write, which is nice. Also, oh, I didn't realize I'm actually missing an optimization here, which is remembering the color, the current color. This should be, yeah, this is something I could do. I could, I'm surprised I didn't do that. It doesn't matter so much in this game here because the density of the pixels is actually quite sparse. It's mostly empty space in our game. But what you can do, yeah, is just have a variable that holds on to your foreground and background color, and only do this setting of the foreground and background color if that has changed. That being said, it's possible that behind the scenes, this actually does that internal optimization. It might tell that this is not changed and therefore not do an output to the console. That's entirely possible. Anyway, and then we write the glyph and then set the flag as not being dirty. So the advantage of this is I could just sort of spit things out. One of the things I sort of had planned to do is add in like sort of multiple layers to the frame buffer, so that there's sort of a base layer, which maybe would be for like the drawing of the map, and then a layer above that for maybe the characters, and a layer above that for overlays like the targeting beams, lasers, then maybe more stuff for dialog boxes and such that when I set a Chixel, for example, over here, set Chixel over here, I'd also specify what layer to put it on, and then it makes it very easy for like when you close a dialog box or you want the special effect of the laser beam to go away, you just clear out that one layer, but the information behind it would be preserved. Instead, I didn't get around to doing that, and instead I set up this sort of redraw request area where when I did do something that would sort of be overlaying on the map, I would just sort of define, I would add to this list of rectangles. I would just define a rectangle on the screen and say, these pixels map, you're going to have to redraw it. And it was actually responsibility of the map to redraw those pixels, which I don't think was as ideal. I really intended to do the multiple layer thing in the frame buffer, and I don't know, for whatever reason, when I was actually going at it, I did this redraw request thing, which ended up being a little, well, it worked perfectly fine and fast, but it's not really as portable or flexible or anything. So I wanted that. I also thought that with those layers especially, that you could define sort of more sub-regions. You can see the frame buffer here does accept something about its left top corner and its width and height. And the idea was actually maybe even to instantiate multiple frame buffers and have them run independently, but that didn't really come up. So I think there's room for making this a lot better and a lot cleaner. And then we're starting to enter into more like an ncurses library type of area. Google ncurses and you'll see what I'm talking about. It's a library that you can use for text-based application that handles things like windows and dialog boxes and that sort of thing, and redrawing and dealing with overlays quite well, which is sort of what we're doing here. Anyway, so that's that. So that's sort of the background that was involved. So the main loop of the game builds a map. The map is basically just something that holds floors. Like, literally, that's basically the job of the map. And the floor is actually a really heavy-duty class that probably deserves to be broken down into 2 or 3, maybe subclasses to split up a few of its responsibilities. But the biggest thing the floor is responsible for is, first of all, it reads in the floor map for the appropriate level, right? So it gets instantiated with the floor map. So map here. So I've got this floor maps class I showed you before, right? And basically floor maps just has 2 primary things. One, it has an array of strings, which is the array of floors. Floor index 0 through floor index 13. Yeah, that's correct. So there's 14 floors in all. And when you're in the game, it tells you what floor you're on or what sublevel you're on, and we offset that by 4. So I think you start on floor 5 and you end on floor 18. But yeah, there's 14 floors in all. So that's what map just instantiates a bunch of floors by passing in a particular string, and then floor then splits that string into lines and then goes through and instantiates an array of tiles that is appropriate for the width and height based on the information we get from that string, and then instantiates all the tiles with the character of that string, one character at a time. And then the other thing that it's responsible for, so it sends, not directly, but it sends to the frame buffer the information about drawing the floor the map to the screen, basically, including trying to recenter things on the main character, and that's its big thing. It also keeps track of what characters exist on its own floor, which can include the player character as well as monsters. And that's it. And everything else about here mostly deals with redrawing. In the update tick over here, you can see it attempts a recenter if appropriate. It redraws those requested areas. I was talking about the recs that get defined in redraw requests. And if this update is to do a tick in this case means we're processing one turn of game logic. So if that happens, then we process the player character, then we process the other game characters, and then we redraw things, and that's it. So yeah, it redraws the map, it runs the characters, and then draws the characters, including the game character. And that's that. Tile class doesn't do much. It just it's responsible for parsing that one character from the map, and then depending on what the character is, it sets itself. It defines its own type. Some of them, like if it finds the @ symbol, that's where the main character gets spawned, and then the default operation, it checks to see if it's a number between 0 and 9. That's a special item spawner logic in floor maps that I'll look at in a moment, assuming I remember. Otherwise, it checks to see if maybe that symbol belongs to a monster. Otherwise, it checks to see if that symbol belongs to an item. And if it doesn't belong to any of those, it just creates a dummy piece of furniture with that name. So we got a couple of things in there to represent like chairs and tables and things like that. And so it just generates something to fill that gap so it doesn't error out. And yeah, that's it. It's got a little bit of is walkable, is lookable logic, and then it can draw its own tile there. And this is how it keeps track of whether the player has seen it or not. We don't have actual line of sight code in here. Well, we sort of do, actually, and I'll look at that in a second. But for the player's vision does not use line of sight. It's just a radius around itself. The idea with that is that it actually represents a variety of different sensors that the robot has. Sound, heat, X-ray vision, so we're all put together. If you have better sensors, you just have a larger sight radius, and that includes going through walls, and that's fine. It's a lazy, easy way to do it, but it's actually relatively functional. So what the hell, right? If it's shitty but it works, it's not shitty. So there you have it. Right, so that's the tile class. So next thing to talk about is probably the character class itself. This is the base character class. This actually, I should actually have had it be virtual, or abstract rather, in that you can never instantiate a character directly. That is true. In fact, if I put the abstract word in here, abstract, everything should compile, because we literally never instantiate character directly, and this would actually be more accurate over here. So it handles some base stuff. It's got this shitty copy constructor, and I know this is not the way I should be copying things, but it keeps causing me problems and biting me in the ass, but there you go. Yeah, it's got 3 constructors, mostly. This is how you would normally actually instantiate a character in the world. This is just if you're doing prototypical characters, which if you've ever watched the Project Porcupine stuff, you can see I'm kind of a fan of that. Like, I instantiate a bunch of, like, the monster characters. I have a class here called Monster List that instantiates each monster, as well as associated to its letter. So, like, F on the map represents a reptoid foot soldier, and this is all just made in a dictionary. So there's a dictionary that maps F to a reptoid foot soldier, which I define here. But when we actually instantiate in the world, all I do is, see, if we hit an F when I'm reading the map, then I look that up in this monsters dictionary, and then I find this monster here, the reptoid foot soldier. This is the prototypical reptoid foot soldier, and then I just make a copy of this object and drop it in the world. So at any given time, there are tens or dozens. Well, tens or dozens. That's not, there's X number of these copies of this monster in the world, but this prototypical one is never in the world, never takes damage, never does anything. It's just what we copy everything from. And that works out pretty well, so that's why you need the copy constructor, and again, it's very shittily handled. Don't do what I do. But it's an idea. And we've got some properties, so characters know where, what tile they stand on, what their XY coordinates are. They all have a chixel, right, that represents their character that gets rendered out. They belong to a faction, which is mostly just whether it belongs to whether it's the player or whether it's an enemy. I could have just done a direct comparison. If this character equals player character, then obviously it's me, otherwise it's an enemy, but theoretically you could have had friendlies or neutrals or different things like that. Name, description, some stats over here, health, hit bonus, dodge bonus, like these are all things that are shared both by players and monsters, so they're over here. Lack of comments, not particularly logical ordering of things, especially late, Sunday especially, things just get jammed in wherever. I don't think about the placement, because at that point it's not going to save me any time. The first half of the jam, you think about placement because having things named well, put in a good place, accessed in a good way will save you time in terms of debugging and finding things. And then at the end, I'm just like, nope, I don't care. Just throw it in anyway. The base update function of the character doesn't do much. It just decreases the cooldown counter. Monsters that use a ranged attack then trigger a cooldown, so they can't just spam you with ranged attacks. So they only act every third turn if they do a ranged attack. So that's all. Take damage. What happens when a character dies? It just makes sure to remove itself from the tile and remove itself from the floor so it doesn't get updated anymore. And really, this tile reference and this floor reference is probably should be the only places where these characters get referenced. Therefore, that should cause them to get garbage collected. It's a small enough game, and it doesn't get like played for long enough for any memory leaks to be noticeable, but I think that probably cleans it up. And this is how something moves. Move by is actually the only thing we use directly. I think move to... yeah, I think this could have been set... That's kind of curious, actually. Out of curiosity, if I set this to private... Is that... No, that's not happy. Oh, because it's virtual. Yeah, so it does... But protected? That's probably fine. And then it doesn't match anymore. Okay, but I don't think this gets called directly, despite being public, so it probably could be refactored. Mostly, monsters, monsters and players probably just use move by, which then calls move to. So anyway, this just checks to see if the tile we're trying to move into is a legal tile. Make sure it doesn't have a wall there or a locked door, for example. And if the tile we're trying to move into has another character, then we will try to melee attack that character. Melee attack checks for factions so that monsters don't accidentally actually hit each other. We will attempt to attack the other character, but in there we'll verify to make sure it's not actually our friend. And that's it. You know, is it walkable? If it's a closed door, then we can open a door. We spit out these messages. So the game is set up basically as a singleton-ish sort of. So this game.instance gets the game and adds a message to the queue that things have happened, and that's it. Draw range attack is one of the things where it's like I was super not happy about having written things like this. I would have preferred a better centralized sort of animation system, an overlay system, and whatever to make these things a little bit better. But we're going to talk about a couple of things here. The utility draw path and where these tiles come from. That's going to be an important thing that we're going to talk about soon. This is how we try to shoot. So you actually don't I don't just pick a direction to shoot in. You actually fire towards a particular tile, and then the shot doesn't keep traveling after that, which could be something we could adjust. But it just fires towards a particular tile, and if it hits anything along the way, you know, like a wall or a critter, then it deals with that. Roll damage, melee attack. You can see here we don't attack the same faction members. And then we do the attack rolls, very Dungeons & Dragons. We roll a number from 1 to 20. Again, this is exclusive at the top here, so 1 to 20. You miss if you don't roll a 20 or if you don't roll above the dodge bonus. And then we apply the damage, and, you know, maybe it dies, maybe it doesn't. Open door. So that's the base character. The player character class has a little bit of extra stuff here because the player character has energy that it cares about. Because this is one of the central parts of the game is your battery power is extraordinarily low and your capacity is not that good either. You're trying to find the MacGuffin, the Yandorian power cell to fix all your power problems. So there's a bunch of stuff in there, vision, this money system, which is metal scraps in the game, and a few things like that. And then we set this character's stats based on the player character's defaults, which are just these constants over here that we can tune. But yeah, that's pretty much it. Just the energy management, the vision radius, and the queuing of moves, which is quite important. When the player hits a key on the keyboard, it doesn't instantly move his character. Instead, it queues a certain move, and then when it's time to process the turn in the floor, that floor update, then that's when the move actually happens, which keeps things nice and clean. There's the actual player override of the update function, where it checks to see if there's a queued move, and it checks to see our energy situation. And that's it. It overrides the move to a little bit as well. Because the player and only the player can attempt to open locked doors. That's the thing here. So here we check to see if the place we're trying to move to contains a locked door. We will attempt to unlock it. Then we do the normal move logic. If the move completed, then we remove some energy from the character. And the player character is also the only person who can pick up items. So if we end up on an item on our tile, then we pick that up. And then we update the vision, which just alleviates some of the fog of war. It flags tiles as was seen equals true. Here's where we pick up items. So we pick up an item, it goes into our inventory, unless it's of type monies, in which case, so things that are money have a value, we pick that up, and we can remove items, and we can use an item from the inventory. It's part of our user interface. I've got a keyboard handler class over here, which handles every keyboard hit. It's got different modes that you can be in, depending on if you're looking at the inventory, or you're aiming, or you're just roaming around the world. But that's what handles there. So one of the modes in there is to look at your inventory, and then you can use an item from there, which is what happens here. Some items, when they get used, they get consumed, like batteries and welding kits. They heal you or give you energy. But some items will actually trigger equip. They will try to equip themselves instead, which is what this happens here. And we've got a couple extra functions here because the player can go up and down stairs and can therefore change his floor. And then we override the player's shooting a little bit because of energy requirements and so on. That's the player class. The monster class is actually a lot simpler than the player. The only thing it really adds is AI logic. The monsters, they have a firing range. If they have a range attack, they have a maximum range. They might have ammo, and one of the types of monsters actually tries to run away from the player, so they have a minimum distance over here that can be set. We check to see if we can see the player using this utility.generate path that we're going to talk about in a moment. So while the player's vision is not based on line of sight, the monster's vision is. They cannot see through walls. They will only chase you if they can see you, and they will run directly towards you. If they lose sight of you, they will keep running towards the last spot where they saw you, and that is enough to make the monsters feel kind of like they see you and they chase you. You can every now and again duck around a corner and lose them, and they won't roam around looking for you. They'll just sort of stand there. If they can't see you, they just stand in place, and that was by far good enough for this game. Nothing else was needed. When a monster dies, it drops metal scraps. And yeah, there's this update loop with all of its AI logic in here to try to find the player. And this is how it tries to move towards the player over here. Not a whole lot to talk about. All right, let's go into utility. Generate path. So one of the reasons I wanted to do this text-based roguelike is kind of sort of because I wanted to reinvent the wheel in a certain extent. When I started programming, it was in the days of DOS. And while I never really did much in the way of pure text-based applications, still, I mean, you could go do graphics there. You would have these sort of magic assembly bits that you could twiddle, and it would cause your DOS computer to change from text-based to, 320 by 240 resolution, or a whopping 640 by 480 resolution. So you would do that, and then there was another couple of bits you could twiddle in assembly that would set a value of a pixel to some color, and then you would go and you could write functions to draw a line, for example, which is not the simplest operation. It's technically non-trivial. How do you draw a line on a grid? If you've got point A and point B, how do you draw it and make it look good? And there's a few different ones. We use Bressenham's line algorithm here to do that. And if we go into the how can I show that? I'd have to pick up. Yeah, it actually has to pick up a ranged item before I could demonstrate that, unfortunately. But yeah, this is the code where going from point A, which is x0, x1, to point B, which is, sorry, x0, y0 is point A, x1, y1 is point B, and we just sort of iterate through that. And what we do is we build a list of tiles along the way. So from point A to point B, we generate an array of tiles, which is just every tile that line crosses along the way. And that is used for the monster vision. It's also used for all of our firing calculations, so that we know what we hit. Here, this doesn't stop. It doesn't care what it hits along the way. It has no logic in here. It doesn't care. But if we go back to the character fire towards, what we do is we generate that path. We get a list of tiles, and we go through each tile, and we stop if we hit a tile that is lookable, is a tile that A, you can't see through, but also you can't shoot through. Represents a wall, a door. Debris is interesting. It's a tile that is not walkable, but is lookable. You can see over and shoot over debris, but you can't walk through it. So this checks to see basically, mostly if we hit a wall or a closed door. And and then it keeps going through this list of tiles, and maybe we hit a character instead, in which case that's when we stop processing over there. So that's what that utility function does. That generates the path, and then we have a related function here to draw the path, which takes in a list of tiles, which is generated from this generate path over here, and it draws it out. Basically, it goes through each one of these tiles and then draws a character. It tries to figure out with get character for beam if we're trying to write a diagonal line or a vertical line or just a horizontal line over here. So that's what it does, and it can take a boolean as to whether it should stop drawing a line if there's a wall or a character there, because that's where our laser beam would sort of stop at that point. So that's that. Items themselves, for example, are particularly interesting. Again, I've got this shitty copy constructor that I just hate, and I gotta stop doing that, but I do. This item list holds a list of items paired with symbols that can appear on the map over here. So, for example, this percentage sign is a small battery. That's because in classic roguelike games, percentage sign represents food, and batteries are basically effectively food in this game. Uppercase B is a large battery. Uppercase W is a welding kit, which is a healing item. It's basically like a med kit, right? Lowercase w is WD-41, which is a smaller health kit. And a capital D is duct tape, which is a very large health kit. Exclamation mark is your access pass, your keys, your one-use keys for doors. Dollar sign is some metal scraps that is on the ground that you can pick up and is basically the currency of the game. An an ampersand symbol is an unpowered warbot. We had a few of those lying around to try to have the theme going around that there's a bunch of other warbots, but none of them are functional except you. And a capital Y is the winning item. This is the Yendorian power cell. You can see on pickup, it triggers a function called onPickUpYendor, which simply says game instance victory. So these are items that we reused a lot. But in addition to that, I talked about how in floor maps over here, so when we read it in this, so for every time we hit one of these hashtags over here, hash symbols, this would be a wall tile, for example. This is a downward stair. A plus is a closed door. A star is a locked door, although it doesn't appear as a star in-game. It appears as a plus, so it just looks like every other door, except it happens to be locked. Also, I think it gets highlighted in red in-game. But so we have, some things have these symbols, but then the numbers 0, 1, 2 over here, and then there's another 0 here, and a 0 there, for example. So on every floor, what we do is we have this list of item spawners, and this is floor index 0. The item with the character 0 is this, so I can make unique items that don't get reused ever over here. So the item 0 on that first floor index 0, the place that's got the 0 on the map is a bucket. Now it doesn't get rendered as a 0 in game. It actually shows up as this chixel. It's the carrot, the little hat here, because it's a head item, in blue. So that's what actually gets rendered for this particular item at that spot. And then we give it some custom values here. When you equip this, it gives you +1 damage reduction, but lowers your vision radius by 1. When you unequip it, the opposite happens over there. Bent girder, so this is the 0th floor, item number 1. So 0, 1, 2. Oh, sorry, no. Oh, it's there. Oh, it's slightly out of order. Yeah, that's okay. This is the bent girder, which increases your melee damage. And then over here we had the webcam, which increases your vision radius. But the webcam and the bucket are both head slot items, so you can't wear both. One replaces the other. So that's how I did that sort of uniqueness. Maybe there should have just been one big library. But this avoids the problem of having to come up with a unique symbol on the map for everything, right? Because this reading through this string requires that each one of these symbols is meaningful to my level generator. And I didn't have, sort of infinite characters to use and remember. So instead, each floor was able to have item 0, 1, 2, 3. In fact, it technically supported up to 10 unique items per floor, although the most I ever got was, 3 on the first floor. A lot of them had 1, or some of them had 2. Other than the first floor. So that's those items. Let's see, what else? Fabricator upgrade. This was just a list of upgrades that would sit around in, I think in game, is that where we set this up? Yeah, these are all the upgrades that you could buy from the fabricators. If you go in there, you spend your metal scraps, and you can get these various upgrades over here. So that's just a placeholder. But yeah, when you're in a fabricator and it engages that game mode, it prints all these out, and each one of them, again, I make use of those sort of anonymous functions, these lambdas kind of thing, that when you purchase this first one called Improved Impact Dampening, what it does is it runs this function here, which gives your character 10 extra health. That's what that one does. This one here gives us you +1 accuracy, and that's all it does. It expects you to give it, when you run this anonymous function over here, it requires the player character as a parameter, and then it runs it here. It just gives you +1 hit. And that's a really easy and awesome way to do your upgrade type of systems. You just have these functions, and you can make any number of upgrades that do anything you want just by running some code over there. Very, very convenient. I think that's it. The intro is nothing fancy. If you read through this, it's just a bunch of like literally sequential like printing out. This does not use the frame buffer. It just writes to the console, sleeps, writes some more to the console, sleeps some more. Sometimes it's got a loop when it's wanted to show percentages, but that's it. It just runs up and down. Not very sophisticated, but it works beautifully. So here's the keyboard handler, which can have modes. Mostly, it's actually in the game object is where we keep track of what keyboard mode you're in, what input mode you're in from over here. But and all this keyboard handling stuff used to be in the game class, but I moved it to a separate thing. They're just static functions. So this is a keyboard handler. Basically, you just run update keyboard. And then what it does is it's got a few keys that are universal, including some cheat keys, but mostly the exit key over here. And then what it does is does a switch based on your current mode, and then it runs another sub-function. This, rather than do it this way, it could have been a dictionary with, again, like with the value being an action. So you could pass a function in there, for example, but it doesn't really matter. So here it calls the appropriate keyboard handling function for your mode by passing it what the key press was. So here in normal mode, for example, we check whether you're using arrow keys or whatever. This could have been switch statements, except they can't really, because it doesn't always compare the same thing. Most of the time we're comparing ckii.key, but every now and again we actually check key car. So you can't really do a switch. So having this be an if else, it doesn't look particularly pretty, but it's fine. And then we just call the correct sub function based on that key press. So this is lengthy and kind of repetitive looking, but it's very simple what it does over here. If you hit F in normal mode, it actually engages aiming mode. So it just sets the input mode to something different, and then we would be using a different function over there. And that's it. That's pretty much the gist of the program. As with every game jam stuff, at some point the code gets a little bit messy, but it works, and I was pretty happy with how it came out, actually. We got a lot of content in here. There's a lot of different modes. If you do go over to, the Ludum Dare site and just try out some of the random games from this Ludum Dare, there will be some that are much, much better. Pay attention if it's a compo or a jam. The compo is the single-person 48-hour thing. The jam, you can have a team of people. You get 72 hours. You can use pre-existing assets. So those will look a lot nicer because they tend to have dedicated artists and dedicated sound people, not to mention the extra day, for example. But I'm really happy with the amount of content we've got in there, and I think it would look favorably against a lot of games. I mean, there's no voting. This Ludum Dare, normally there is. This one's a special one with no voting. I would not expect to win with this game, but I would expect to place pretty well. At least top 100, probably more like top 50, potentially. It's a little hard to judge because obviously graphically it's not very impressive, but let's see here, properties. Oh, that's right, I didn't actually skip the cutscene this time. So it's got sound effects and little things like that. That's the intro. So yeah, it doesn't necessarily impress at first glance, and yet I think it's a very, very good sort of love letter to classic, true roguelike games. Not roguelikes like people use for every other game these days, but a true roguelike game, with the exception that does not have randomly generated content. But other than that, it is very, very true to the form. And certainly, if it had more than 48 hours, that would be the next thing we would put in there. And it would be pretty easy. I mean, I have a tutorial for procedurally generating this stuff, and we've done it in the past 4 games before. It would definitely be easy to go ahead and mod that in. So yeah, so I want to say thank you to everyone who watched the live stream. I live streamed the whole thing. You guys are super awesome, and these are not else. No, I guess that's fine, because it wouldn't be more than one, but they could be else's. Anyway, it makes a world of difference. I'd find it harder to keep myself as motivated as I do if it weren't for you guys watching and cheering me on when we do this. Although I will say that if you have any desire whatsoever to ever make a game, do try to participate in these game jams. They just force you to sit down and do it. everyone who wants to be creative, whether it's, you know, making a computer game or writing a book or learning to play the guitar or whatever, you overthink it, and everything has to be perfect and everything has to be just right, and therefore nothing ever gets finished. Whereas here, you have no choice. You have to just make it work, and who cares if it's pretty or if it's perfect or anything like that. Just get it done, and you have a strict time limit. And it teaches you a lot about prioritizing. With every Ludum Dare, I get a little bit better about managing my time. I say that. Wow, what a goddamn lie. I mean, I do, in a sense, but I do always fall into the trap of making things that are just a little too ambitious. Ink was a good example of that. I think it could have been great, but we'd spent a lot of time on the map generation, and there were a couple of things that suffered. I think Dr. Deckenstein is by far the best game I've ever made. Personally, I really, really enjoy playing this game a lot. I think it's fantastic, but we ran out of time for sound, and I think that's one of the reasons it didn't rate as highly as I think it deserves it. It came out 79th overall, and when you compare it, like, to Growth Industries, I thought was very, very good and well deserving of its ranking of 19th overall out of, I don't know, there was like 2,800 total entries. Not all of those were in compo, some of them were jam, so I don't know, but, you know, 16th overall was exceptionally good. But Hell Wars, you know what, is a lot of fun, 33rd overall, but Dr. Deckenstein is way better than Hell Wars. In fact, I like Dr. Deckenstein a lot better than Drill 18, which came in 6th overall. Although, to be fair, this was also a really fun game, and I can see why people associate it. So I'm bitter. Dr. Deckenstein is one of those things I'm bitter about. I think it should have rated much, much higher than it did. Even though it did fine, I think it should have rated higher than it did because I think it's a fantastic game. By far my favorite. I think the balance is awesome. It's really enjoyable, good replayability, but it doesn't have sound, and I think that really held it back. Dr. Deckenstein, Wake Up Call, has beeps. It's got sounds, technically. It just, that's all it does. Console.beep. Nothing fancier than that. It would have been nice to have actual real sound effects in there, but there's not a singular library in C# that will allow playing of sound files on all computers. You can, like, if you're on Windows, you can use, is it like system.media or something like that, but I don't believe that works on Mac or Linux, and I didn't do extensive testing, so for all I know, maybe something does work. But yeah, but it's okay, we got console beeps, and you know, that's fine. Old school. It's ancient technology. It fits in. So if voting was on for Ludum Dare 36, I would be quite curious to see how this would do. But one of the reasons I went ahead and did this text-based game is partially because there was no voting. It took some of the pressure off and allowed me to be a bit more experimental. I don't know if this, you know, would be really well judged or not really well judged. I think it's a great game. I think it doesn't have replayability necessarily once you've beaten it, because at that point you'll have sort of solved it, right? Because it's not procedurally generated. Although it might take you several plays to beat it. So, you know, treat it almost more like a puzzle to find the optimal strategy to go through. So far, all the comments have been really good, so that's really great. I'm happy to see that. Yeah, so that's it. That's my post-mortem video. Some of the things that went well, some of the things that didn't go well. Again, it's one of those things where it's like, I can't believe the code for this is public because, oh, it's so shameful. Well, you know, again, if it's shitty but it works, then it's not shitty. So it is available on the GitHub page. You can see I ran into a problem at some point with Git not responding. It wouldn't add files. Like git add.a, which is like the most like shotgunny, just add everything, literally wouldn't add files for some reason. So I just deleted the my local repo and then just started a fresh one, and I was a little bit salty, which is why I have fu git. And then everything was fine from that point on. So I don't know what was going on, but I don't know, something was going on there. It's possible at some point that the code here may actually change from the submitted version if people find some bugs. Someone actually had put in a possible error here, but it turned out that they were running on an older version. But, you know, there might be some development in the future. If you do want to download the code exactly as it is from Ludum Dare, you can make sure to go to commits and grab the one that is submission version over here, and just grab that. Like if you clone the repo, you can just make sure to revert back to this particular edition over here. But I'm not particularly expecting to be developing this because I've got too many things on my plate as is. And you know, there's a certain type of purity to what it is. I should add a README file, and I should also add a license. Technically right now it's not open source. It's public source, like you can see the source, but it's not. It doesn't actually have a license that says you can copy it or anything like that. So I should probably do that. I suppose I should probably make it, just put it under a standard MIT license, which you tend to put most things in, which is very, very, very liberal. You know, it's not like people are going to make a commercial version out of the code as is. The one thing I think we did relatively well is the frame buffer, although again, I do want the multiple layer thing. So did we learn things? Yes. I mean, less within the context of the actual Ludum Dare itself and more about the week leading up to Ludum Dare. I learned a lot about interacting with this pure console code, and that was really fun. It was interesting to work within those constraints. And I'm really, really satisfied that I did it. Most likely, next Ludum Dare, I will be going back to something more visual and probably in Unity. But I'm really happy that we gave this a go. And it was a lot of fun. And that's that. Thank you very much for watching, folks. See you guys next time. Thank you everyone who continues to make Project Porcupine a reality by supporting us on Patreon. You guys are supporting us through August and early September, and including these mic check supporters, we've got Drazion, Jan Torivel, Julian Auger Lafont, Craig Mortel, Neil Blakey Milner, Ole Peter Talgo, Wes Oldenboving, Kale the Quick, Valiant Cake Fiend, Aaron Toiveson, Michael McClintock, Marius Fieldvold, Speedy Savant, Jason Yanity, Adjective, Steven Stager, Cupro Panda, Yukofin, and absolutely everyone who's watched, shared, favorited, and subscribed these videos. I appreciate you very, very much.